Hello. My name is Bo Donghou. Our topic of the project is binocular GAN, a GAN for binocular depth estimation. Our group consists of Yu Xiliu, Vicky, Xiao Weiyuan, Jun Weiyou, and me, Bo Donghou. In this project, we pursue training our GAN network on the KT dataset. Along the way, we experienced a lot of setbacks. For example, due to hardware reasons, the training speed is too slow. The modification of the code also took a lot of effort for the four of us. But the result is still satisfactory to us.
GAN is short for Generative Adversarial Network, which is an unsupervised learning method of learning by having two neural networks contest with each other. We choose this topic because GAN is an interesting method with a wide range of applications, such as image translation, face generation. Our purpose is to make it possible to achieve binocular depth estimation. This is very interesting. Let's move on. We divided these slides into 4 parts, and I will do the first half. First, we will introduce the purpose of this project and then introduce our binocular depth estimation. In the third section, we will focus on GAN-based depth estimation. Finally, a conclusion of this project. Our goal, as mentioned at the beginning, is to achieve binocular depth estimation based on GAN networks. For binocular depth estimation, a large amount of label data often requires huge labor costs. So more and more researchers have begun to focus on how to improve the performance of the model without obtaining data labels. Therefore, self-supervised learning has received more and more attention, especially GAN network.
Hi, this is Vicky. I'm going to talk about the method used in our project, GAN, Generative Adversarial Networks. Being different from traditional method, GAN is an end-to-end method as shown in these slides. In order to encoding and decode the image space, we use GAN to train the encoder and the decoder. The box on the left side is the generator. Through this, we can get the depth image, which is also called the fake image, and we compare the consequence with the real depth image. Then we use both the fake one and the real images to train the discriminator first, and use discriminators back to train the generator. So here comes the question. While use GAN to do the depth estimation, what is the best way to compare two pictures which are from the left and the right eyes? If we pose two pictures top and down, then we need to use both X and Y axes. However, if we list the left and right pictures side by side, we only need to find its y-axis. This method works well and converges quickly. Here listed the generative model and the discriminative models we've used. On the left of the slides, we give credit to all the authors of the reference included. So here we have 2 examples of our works. The first line is the original picture. The second line is the pictures from our GAN. The third line is the ideal picture. Another example. During our research, our team have encountered difficulties and debates. The first one is about method option. Instead of use traditional methods such as feature extracting, we use the GAN, which is more difficult but more effective. Secondly, merging pictures from each eye side by side makes left and right image effectively guided. That's all about our research. Thanks for listening.
Okay, let's move on to the coding part. Prior to that, I would like to introduce some challenges we have encountered throughout the whole process. First of all, it is difficult to align the standard depth map with the input map, because the input image consists of 2 images. One comes from the left eye and another comes from the right eye. And later, we adopted the monodepth-v2 model proposed by University of London to generate a matching depth map, which basically solved this problem. Another difficulty lies in setting up machine learning environment. It is also widely known that TensorFlow has a lot of things to do, such as operating system selection, version selection, graphics card or CUDA selection, and so on. It usually has a high standard requirement for computer performance, and sometimes the machine just crashes automatically. Let's begin to look at our code. In the first section, we just simply import those modules we're going to be using in the following sections. After that, in this cell, what we're doing is to set the device and have GPU prepared for further processing. After that, in this cell, we actually propose some static methods for image processing and data preparation. Here we constructed a class called helpers. You can see the methods and operations within are all about image processing. After that, in this section, we can actually load our data set, those images, into our network. With the data prepared, we can actually begin to build our GAN network.
So here is the GAN model, and the reference we put it here. So the pixel-to-pixel class has the following parts. First, initialize the GAN network, and then build the. Then here we build the discriminator and generator network. Below here, we defining the generator and discriminator model. And here we have a preview training. We have a function called preview training process. We present the result contains source image, generated image, and destination image. And then we will plot in the losses. And then train the network and test now the network. And here are the parameters we set. And from the picture here, we can see this row is the input picture, and this row is our answer, and this row is the destination image. So we randomly choose a picture every approach and show the results, how the network works. And then we will show the loss function after every approach. So in the end, we can see we run 6 approach in total. So from here we can see at 6 approach, the losses function looks good, and the GAN network works well. So this is the end of our presentation. Thank you.